We're going to do another example of finding the greatest common factor between numbers, except this example is going to have three numbers, and you need to find the GCF between those three numbers. Just a reminder, factors are the numbers you multiply together to get another number. The greatest common factor, or the GCF, is the largest number that divides evenly into two or more numbers. We're going to again complete this example using factor trees. So we're going to find the GCF, greatest common factor, of 12, 36, and 96. So the first thing I'm going to do is set up my trees. So I have 12, 36, and 96. These factor trees just allow you to know any pair of factors of that number to find an entry point to solve. So for 12, you can either do 3 times 4 or 6 times 2. Let's do 6 times 2. 6 times 2 equals 12. Now I need to stop and think. Can I break 6 down anymore? Yes, I can. 2 times 3 equals 6. Now I'm going to stop and think, do I have any other factors of 2 besides 1 and 2? I do not, so I'm going to circle my 2. Same thing with your 3. The only factors of 3 are 1 times 3. So you just circle your 3. And again, my 2 up here, don't forget about it. You just circle your 2 because the only factors are 1 times 2. Now you have your list for 12. So you're going to pull out down this list. 12 equals 1 because it's a factor of every number times, I'm going to go from least to greatest, 2 times 2 times 3. Now I can move on to my 36, but I can do a quick check first. 1 times 2 is 2. 2 times 2 is 4. 4 times 3 is 12, so I know that this list is correct. Moving on to 36. Again, you can use any pair of factors that multiply together to equal 36. I'm going to use 6 times 6 because 6 times 6 is 36. Now I need to see if I can break down both of those 6's. So if I want to break down the 6, I know 2 times 3 equals 6. And now I'm going to think, well, the only factors of 2 are 1 and 2, so I'm going to circle that 2. Same thing with the 3. The only factors of 3 are 1 times 3, so I'm going to circle the 3. And since this is the same number, my tree is going to look exactly the same. 2 times 3 equals 6. I'm circling my 2 because the only factors of 2 are 1 and 2. I'm circling my 3 because the only factors of 3 are 1 and 3. Now I can write my list. 36 equals 1 because it's always a factor, every number, times, again, I'm going to go from least to greatest, 1 times 2 times 2 times 3 times 3. Now do a quick check. 1 times 2 is 2, 2 times 2 is 4, 4 times 3 is 12, and 12 times 3 is 36. So that's how I know this list is correct. Now for 96. If 96 is a bigger number, if you're struggling with your facts, since 96 is an even number, you know it's always divisible by 2. So you know 2 times something will equal 96. So you can do your long division, and you can figure out what that other factor is if you do 96 divided by 2. Or if you know your 12's facts, 12 times 8 equals 96. So you can start there. Now I move over to my 12. And I know 3 times 4 equals 12. Look at the 3. The only factors of 3 are 1 times 3, so I circle it. My 4 I can break down. 4 is an even number. It's divisible by 2. 2 times 2 equals 4. Circle both your 2's because the only factors of 2 are 1 and 2. Now, don't forget about your 8. You need to break your 8 down. So factors of 8, 2 times 4 equals 8. Again, I circle my 2. Now I need to break down my 4. 2 times 2 equals 4. Circle both of your 2's. Now that I've finished my tree, I'm going to write my list for 96. 96 equals 1. Remember, 1 is always first. Times 2 times 2 times 2 times 2 times 2 times 3. So my list is going in order from least to greatest so that it's easier for me to match up these numbers. Now, with the last example, we just had 2 numbers, so we were looking for a pair. This time, we're going to circle the sets. So every one of these lists has something in common, so we're looking for a set of the same number. So that means there has to be that number in all 3 lists. So I have a set of 1's in all 3 lists. I have a set of 2's in all 3 lists. I have a 2, a 2, and a 2. So I'm going to circle those. I have another set or another group of 2's in all 3 lists. So I'm going to circle those. Now I look at my 3. I have a 3 in my first list, my second list, and I have one in my third list. So I can circle a group or a set of 3's. Remember, be careful. Your circles aren't always going to line up. You need to check and see if that number can be found in every list. Now, I don't have any more factors in my list for 12, so that means I won't have any more groups of numbers because I have a 3 here. I don't have any other 3's to go with this one, so I can cross that one off. Same thing with these 2's. I have some 2's left in 96, but I don't have anything left in the list for 36 or 12 that I can match those up with, so I can cross those off. Now remember, you pull out one number from each of these groups. You just pull out one, and then you multiply those together to find your GCF. So your GCF equals, I pull out one of those 1's times, here's my first group of 2's, I pull out 1, 2. Here's my second group of 2's, so I just pull out 1, 2. And then I have a group of 3's, so I just pull out 1, 3. Now your answer, you just multiply from left to right. So let me set this part up. GCF equals, so 1 times 2 is 2. 2 times 2 is 4. 4 times 3 is 12. So my GCF equals 12. You can also work out this equation piece by piece. So 1 times 2 is 2. Now you have 2 times 2 times 3. So 2 times 2 is 4. And then 4 times 3 equals 12. You can work it out from left to right, or you can break it up and do it piece by piece. But 1 times 2 times 2 times 3 equals 12. So my greatest common factor of 12, 36, and 96 is 12. That means if you divide all those numbers by 12, it will go into each one of those numbers evenly.